Happy e-learning day, ladies and gentlemen. In this lesson, this is going to be our last lesson of this matrix chapter. We are going to get into some of the applications of determinants that we talked about a couple classes ago. So what we're going to do today are a few things. I'm going to show you how determinants can be used to solve systems of equations. I'm going to show you how determinants can be used to find the area of any triangle in the coordinate plane. And I'm also going to be able to show you how determinants can be used to find equations of lines. And so the first thing we're going to do is use determinants to solve a system. And this first thing we're going to talk about is what we call Cramer's rule. Cramer's rule. And here's how Cramer's rule works. It basically solves the system, but gets rid of all the variables. And the way it works is we're going to set up two different determinants in fraction form. And here's what I mean by this. The first thing I'm going to do is if I want to find x, okay, I want to find x first. I'm first going to set up what I call d sub x. And this is the determinant formed when I replace the x coefficients with the results 7 and 9. So instead of 3, I'm going to put 7. And instead of 2, I'm going to put 9. So I'm going to put 7, 9. And then I'm going to put the coefficients for the y's, -5 and 1. Okay, so understand what I did here. I took the results, 7 and 9, and I replaced the x coefficients. Now I'm going to divide this by the coefficient determinant. I'm going to take the coefficients, the actual coefficients, 3, -5, 2, 1. And I'm going to call that d. And when I take that d sub x divided by the coefficient matrix d, when I take these two determinants and divide, I'll get what x equals. Now remember how to find determinants of a 2 by 2. If I want to find the determinant of a 2 by 2, I multiply the main diagonal and I subtract the product of the other diagonal. So 7 minus -45 is 7 plus 45. On bottom, I would do 3 minus -10, so plus 10. So I get 52 over 13. That means my x value for this system would be 4. X equals 4. So if I want to find x, I replace the x's with the results, and I divide by the coefficient matrix. And same thing with the y's. If I want to find the y's, well, now I'm going to do d sub y. So think about what you would do here. If for d sub x, you replace the x coefficients, for d sub y, you're going to replace the y coefficients with 7 and 9. So you're going to have 3, 2, and then 7 and 9. And you're going to divide that by the coefficient determinant. Well, we already know that's 13. We already found it. So once you find that coefficient one, you don't need to do it again. I know it's 13. So I'm going to do 27 minus 14 divided by 13. 13 divided by 13 is 1. And that would be my y value. So the solution to this system would be 4, 1. Right there. So it's just a quick way, if you're pretty good at and quick at solving determinants by just cross multiplying and taking the difference. It's a pretty quick way to solve systems of equations. We'll look at this 2 by 2 right here. And the first thing I want to do is put it in standard form. So I'm going to take each equation and move the x over. So -2x plus y equals -5, and -5x plus y equals -11. If I want to find x, first replace the x's, the x coefficients, with -5 and -11, and then put the y's, 1 and 1. Divided by d, which is the coefficient matrix, so -2, 1, -5, 1. And then I cross multiply. So -5 minus -11 over -2 minus -5. So I have 6 over 3. My x value is 2. And then if I want to find the y's, we'll now replace the y's. So do d sub y. So the x's will stay now, -2 and -5. But the y's I'll replace with -5 and -11. Divided by, and remember I already found out what that d is, so 3 on bottom. So I have 22 minus 25 divided by 3. So -3 divided by 3 is -1. So my solution would be 2, -1. A couple things that could happen, special cases. If you get 0 in the denominator, if the determinant, I'm going to make a note of this up at the top where I have room. If the determinant of the coefficient matrix is 0, so if you get 0 on bottom and 0 in the numerator, think about what special answers you get with systems. You can either have infinite solutions or you can have no solution. And so if you get 0 over 0, this would be a case of infinite solutions. And if you get a different number over 0, that would be a case of no solution. So you can still get your special case answers here when you get 0 in the denominator. And that would be your special cases. This Cramer's rule also works for 3 by 3s. Now it does get a little more messy because obviously it's harder to find the determinant of a 3 by 3, but it's the same idea and same process. And so we'll do one. There's 2 on the notes, but they're done the same way, so I'll save you guys some time, and I'll just do this first one here. So if I want to find x, I'm going to do d sub x, and I'm going to replace all the x coefficients with the results, 1, 0, 2. I put the y coefficients, 2, 0, -4, and then the z's. And I divide that by the coefficient matrix, what we call D. So -1, 2, 3, 2, 0, -4, -3, 1, 4. And now we're just going to find the determinants of both of these. My preference is I like diagonals. However, I do notice that there's a row with 2 zeros in the top here, so expansion could be pretty quick if you like expansion that way. I'm going to do diagonals. That's just a preference of mine. So I'm going to put 1, 0, 2, and 2, 0, -4, and I'm going to do diagonals. So I'm going to get 0 plus 4 plus 0. So I get 4 on bottom, and then multiplying the other direction, I get 0 minus 4, and then plus 0. So remember, I'm going to do the bottom number minus the top number, and be careful here. So it'd be 4 minus -4. It'd be 4 minus -4. So that's going to be 8. So I get 8 in the numerator. And then in the denominator, I'm going to do diagonals again. -1, 2, 3, 2, 0, -4. And again, you can use expansion. 0 plus 6. Let's see, -6 and -4 is positive 24. So 30. Going the other direction, you get 0. And then you get plus 4. And then you get 8 times 2 is 16. So 20. So you get 30 minus 20. So 10. So the determinant of the bottom one is 10. And so that reduces to 4/5. So x I just found to be 4/5 using Cramer's rule. And then I can do the same thing with the y's. What's nice is after you find the bottom one, you don't need to find it again. So I know the bottom one is 10. I will need to find the other ones though. So when I want to find y, I do d sub y. So now I'm going to replace the y coefficients with 1, 0, 2. The x's stay the same. The z's stay the same. And I know that's going to be divided by 10 because I already found that one. And again, I'll do diagonals. -1, 2, 3, 1, 0, 2. So I get 0 plus 3, and then minus 12. So that's -9. The other direction, I get 0 minus 2 plus 8. so 6. So negative 9 minus 6 is negative 15. So I have negative 15 on top. So y equals negative 15 over 10, so negative 3/2. That's the y value. What I will let you do, instead of using Cramer's rule for z also, why don't we just pick an equation and plug the first two into an equation, plug x and y into an equation to find z. So save you a little bit of time here. In fact, why don't I just use that middle one, because I already know what x is, and then I can find z that way. So I'll have 2 times 4/5 plus z equals 0. So 8/5 equals, 8/5 plus z equals 0, so z is negative 8/5. So my ordered triple would be 4/5, negative 3/2, 8/5. So again, it's just a way to use determinants to solve systems, just something different. Is it the most efficient? Maybe not, but it could solve higher order systems, 4x4, 5x5, and say you're allowed to use a calculator. It could go pretty quick that way. So it's just something that works. Okay. There is another example of that. I'm not going to do it. It's the same exact thing. There's no difference. So what I'm going to do is jump down to the next one. Determinants will allow you to find the area of any triangle. Now, it's pretty easy to find the area of a triangle if you know the height and base of it, right? It's just 1/2 base times height. But if you don't know the height, like this triangle down here, then determinants are a pretty nifty way that you can find the area of this triangle. The first thing you need to do is figure out what these ordered pairs are for this triangle. So I'm going to list these out. This is 3, 1. This is 7, -1. And up here, this is 7, 5. Okay. If I want to find the area of this triangle, here's what we do. We're going to say area equals, I'm going to put plus or minus 1/2. Now I'm going to set up the rest of this. I'm going to talk about that plus or minus. It's different than the quadratic formula plus or minus. Here's the determinant I set up. I'm going to take those 3 ordered pairs, and it doesn't matter what order, and I'm just going to list them here, here, and here. So I take those 3 ordered pairs and I list them like so. To find the determinant, though, I need a square matrix. And so I need to somehow turn this into a 3x3 matrix where not a lot of changes are going to be made. So what you do, and this is for all of them, the last column, you just put 1, 1, 1 to create a square matrix. Now, this plus or minus out in front, you only use the one that will make the area become positive. Meaning, if this determinant right here, after we calculate this, if this determinant turns out to be positive, then we'll multiply it by positive 1/2. If it turns out to be negative, then we'll multiply it by negative 1/2. Basically, use the one that's going to give you a positive area in the end. So you don't even really need to know the plus or minus. Just at the end, after you do your calculations, make sure your answer is positive. So I find the determinant. And again, I like diagonals. My preference, if you're using expansion, go ahead. But I list the 3 ordered pairs, and then I just put 1, 1, 1. So 3, 7, 7, 1, -1, 5. And I'm going to do diagonals. So -3 plus 7 plus 35. So that's going to be 39. The other one would be -7 plus 15 plus 7. So 15. And then 39 minus 15 is 24. That's the determinant of that matrix. And so now I'm just going to take half of that, and I find my area to be 12 square units. So again, it is a way you could find the area of any triangle in the coordinate plane. You list your 3 vertices, 1, 1, 1, find the determinant, multiply by 1/2. So that one I think is a pretty cool application of determinants. Going off of that, we're going to talk about a couple other things, but they're kind of based off that principle. Okay, so there's a couple other things you could do. You could determine if 3 points are collinear. if the points are collinear, think about that. If I have 3 points and they're collinear, and I draw a triangle, think about trying to draw a triangle with 3 collinear points. It wouldn't have any space, if you will. If I try to draw a triangle with 3 collinear points, there's not going to be any area, I guess you could say. So if 3 points are collinear, what should their area equal? And that would be 0. Because if 3 points are not collinear, let me draw 3 points that aren't collinear. You don't have to draw this. Here, here, here. And I connect them. There's going to be some sort of area that exists. But if they are collinear, there won't be any area. It'll be 0. So basically, find the area of this, I'm going to put in quotes, triangle. And if the area of that triangle is 0, then you know that they are collinear. So I'm going to try to find the area. I'm going to list those 3 ordered pairs, -3, 5, 6, 1, 10, 2, and then 1, 1, 1. And if this turns out to be 0, then I don't even need to worry about the 1/2. The 1/2 is kind of irrelevant. If this is 0, then I know it's going to be 0. So I want to see, does this equal 0? That's the question. And so I'm going to do diagonals. Give myself a little more space to work with here. So -3, 6, 10, 5, 1, 2. And I want to see, does this equal 0? So -3 plus 50 plus 12. So that's going to be, what's that, 59? 47 plus 12. And the other way I get 10 minus 6 plus 30. So 34. So 59 minus 34 is 25. So not 0. So I would say, for my final answer, the points are not collinear. If it did turn out to be 0, then I could say that they are. And the last thing, going off of that even a little bit farther, we're going to use that same idea, same concept. It says, find the linear equation that passes through these 2 points. And again, we already know how to do this. This is just applications of determinants, things that you can do with them. Are they always the most efficient way? No. But what a lot of math is just providing you different opportunities and different methods to solve similar types of problems. Take when you solve a system and we teach graphing, substitution, and elimination. They all get you to the same place, but it's just different routes and different avenues, and that's all this is doing here. So if I want to find the linear equation that goes through these 2 points, well, we're going to use these 2 points and some other point, we'll call it xy, and we need them all to be collinear to have a line. So in order for these 3 points, this one, and this one, to form a line, then the area would have to equal 0. So what I do is I'm going to put xy, and then -4, 3, 2, 1, and then 1, 1, 1. And I'm going to set this equal to 0. And in solving, I'm going to get an equation with x and y in it, and that's going to be my linear equation of this line. So you can do expansion, you can do diagonals, it's up to you. X, -4, 2, y, 3, 1. So I get 3x plus 2y minus 4. The other way I get 6 plus x minus 4y. So here's where you need to be careful. I'm subtracting that whole quantity. So I take the bottom quantity minus that top quantity. 6 plus x minus 4y. And I set this equal to 0. And so from here, I just need to simplify this equation. So I'm going to turn that minus into a plus and change all these signs over here. And then just combine like terms. So 3x minus x is 2x. 2y plus 4y is 6y. Minus 10 equals 0. And you can write your answer in multiple ways. I mean, you guys are most familiar with slope-intercept form. If you want to write your answer in complete standard form, here's standard form, right here. If you want to write your answer in slope-intercept, you could do that as well. So subtract 2x and divide by 6. 10 over 6 is 5/3. Either way, I would accept either one of these answers, the one in standard form, or if you want to put it in slope-intercept form, that's up to you. But understand what your answer is. Your answer is this is the equation that would contain those 2 points, using determinants and areas. So, again, just some applications of determinants that I think are pretty interesting. Now you guys will have your assignment to work on. Next class we'll have a review day, and then plan on a test the following. So for the gold day, your test will probably be next Tuesday, right now. See ya.